Linear regression. First, let's practice graphing lines. When you have an equation written in slope of intercept form, y equals mx plus b, m represents the slope, aka your rise over your run. B represents your y-intercept. So when we have the equation y equals 2x plus 4, that means the slope, or m, is 2. The y-intercept, or b, is 4. So on our graph, let's first put a dot on 4 on the y-axis, because that's where our y-intercept should always be. And then use the slope. When it's 2, it's technically 2 over 1. So you rise up 2, so 1, 2, and you go 1 to the right to produce another dot. All it takes is 2 dots, but let's keep going to practice. Up 2, 1, 2, over 1. And then you connect the dots with a straight edge to produce a line. Please make sure your lines have arrows to indicate that they run forever. And label your y-intercept. So this is 0, 4, and another point. So I'm going to use this one, which is at 2, 8, please. It's also asking, what is the x-intercept? So if I were to go down 2 to the left, I would eventually hit my x-axis at negative 2. Or negative 2, 0 is my x-intercept. Now we're going to talk about the domain. And we kind of talked about it on the previous relations and functions video. But anytime you have a line, the furthest left it'll go, because there's arrows down here, that means it's going to keep going forever. So it goes forever until negative infinity. And if I trace upwards towards the right, it has arrows again, so it goes to positive infinity. So if I was using interval notation, it would look like negative infinity, comma, infinity with parentheses. If I was using inequality notation, it would be negative infinity less than x less than infinity. Or you can say all real numbers with that symbol, just like that. The range, again, refers to how low to how high the graph is. So the lowest portion is down here, but there's arrows, so that means, again, negative infinity. And then when I trace it all the way up, there's arrows again, so that's positive infinity. So the range will look just like the domain when you write it in interval. When you write it in inequality, you got to remember to use y in the center, because y is your variable for range. But again, you could also use the fancy symbol to represent all real numbers. You should also be able to graph a line when it's written in standard form, ax plus by equals c. If you have those sharp algebra skills, you can always convert it from standard to slope-intercept with some careful skills. If you do not, you can graph it by other means. The first one we're going to call the cover-up method. So if I want to look for the y-intercept, I'm going to cover up 2x. In other words, make it disappear, and I'm only left with negative 4y equals negative 8. Covering up means I replaced x with 0. And so 2 times 0 is nothing, so it disappears anyways. So that's why it's called the cover-up method. Now you can focus on solving for y. So you would divide by negative 4. which means y is by itself, and negative 8 divided by negative 4 gives me a positive 2. So your y-intercept would be 0, 2. And you could graph that right there. I'm going to use the cover-up method to find my x-intercept now. So this time, the negative 4y will disappear because you replace y with 0. And that leaves you with 2x equals negative 8. So now you divide by 2 on both sides. So x is equal to negative 4. So your x-intercept is negative 4, 0. So right here. And all it requires is 2 points to graph a line. And we have 2 points, our x and y intercept, so we use a straight edge to connect them. You could always make it extend beyond the points, which is great. And use arrows at the ends. We can now count our slope from our x-intercept to our y-intercept. So we rise up, 1, 2. We run over, 1, 2, 3, 4. So for our slope, it's our rise of 2 over 4, a run of 4, which reduces to 1/2. So up 2 over 4 is 1/2. And then the domain and the range are exactly the same as the previous example. So just copy and paste the information, please. Now we're about to get into the actual linear regression piece. When we're dealing with linear regression, we're going to have graphs called scatter plots. It's used to determine whether a relationship is shown between paired data. The relationship for the data is what we call correlation. Correlation has a number between -1 and 1. And we're also going to be finding lines of best fit, or the best fitting line. And it's going to be the line closest to all possible data points. So there's 3 types of correlation: positive correlation, negative correlation, or no correlation. Positive correlation is where the y, or the dependent variable, tends to increase as x increases from left to right. So there's an upward trend. So as you can see on the graph of the positive correlation, all the dots appear to be going upwards as I move from left to right. And then on a negative correlation, y will decrease as x increases as you're moving from left to right. So it's a downward trend. And then no correlation is pretty much random. You can't determine what's going on. Sometimes it's up, sometimes it's down. It's all about what is the majority of the data doing. If r is a positive number, the closer it is to 1 shows how strong of a correlation or the relationship is. And then the closer it is to -1 shows how strong of a negative relationship it is. Just FYI tidbits. So now we're going to practice. We have a table below that represents the number of people, y, who attended each of the first 7 football games, x. So y represents people, and x represents games. Let's make that known and clear first and foremost. So this is people versus games. We're going to approximate the best fitting line for the data. So this requires a graphing calculator. Or you can use Desmo's graphing calculator online if you don't have a graphing calculator at home. but you have the internet. So turn your calculator on, and then you go to Stat 1 for edit. And now enter the information. So put all your X values in L1. And hit enter after each one. So that's 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7, enter. Then go to L2, make sure you go all the way back to the top and line up with 1 before you hit the Y value that goes with 1. So 722. Again, hit enter after each one. 763, 772, 826, 815, 857, and 897. All right, double check that everything matches with the data, make sure the X and Y's pair up as they should, and that you entered every number in properly. If you didn't, please fix it before we move on. Once everything pairs up, then we go back to Stat. Now we go to Calc, and we choose option 4, LinReg, for linear regression. The first thing says X list, so where are your X's? Our X's are in L1. That's default, don't change it. Then it's asking where are your Y's? Our Y's are in L2. Again, do not change it. Then go down to calculate and hit enter. So they give us the linear regression equation. Your job is to write down that equation. So write it down in slope-intercept form. Y equals, and the calculator tells you AX plus B. So for us, it's Y equals, and A is 27, so 27X plus B is 699. We're going to round it to 3 decimal places. So 699.429. So 690. Stop. Open. Stop. You're messing up right now. I'm sorry. It's freezing. All right. 699 point. What did I say it was? 429. Ooh, let me write that nicer. So 699.429. So this is the equation. So then it wants us to use the equation. So let's write the equation again. Y equals 27x plus 699.429 to predict the number of people who will attend the 10th game. So again, X represents game. So that means we need to replace X with 10. So when we replace X with 10, we would go ahead and do the order of operations. So 27 times 10 is 270. Then add it to 699.429. And you would get, I know it's definitely a 0.429. That's not going to change. We have a 9. Then we're going to have a 6. Carry the 1 over. So 6 plus 2 plus 1 is 9. So 969 people are expected to attend game 10. With a calculator, the calculator will do the order of operations for you. If you go to alpha trace select Y1, open parentheses, type 10. We're doing function notation. And then hit enter. Uh-oh. Okay, I'm sorry, guys. There was something I forgot to do. Back to stat, calc, linreg. So we have to store the equation in order for that feature to work. So when we store the equation, we got to give it a name. So we're going to name it Y1. So alpha trace. Oh goodness, why is my computer freezing? Stat, calc, linreg. Alright, so again, I was in the process of naming the equation I wanted to store. So alpha trace. We're going to name it Y1. Make sure you do that before you hit calculate, and then you can use this feature. Alright, so now when I recall it, alpha trace 1, I'm saying I want you to find equation Y1 and substitute x with 10. That's what you're telling it to do. And this is what you'll get. 969.429, which is what we got. But if you don't want to use a calculator for that nifty trick, then yeah, take it step by step like I did. Alrighty. So I want you to complete this one on your own. Again, if you don't have a graphing calculator, you can use Desmo's graphing calculator. They should be able to do something very similar to this. And if not, get here as soon as possible to be able to use the calculators in class. But this concludes our notes for this lesson.